Brathwaite. I'm a fourth year student at Monash University, and today I'm going to be talking about filters, low and high pass filters that is, and I'll be using my DDJ-SX as a prop to help me explain some of the stuff that I'll be talking about. Before we get going, I'd just like to say a big thank you to my prof, Dr. Robert Hawks, who has been a great help with helping me to understand some of the concepts in digital and analog electronics. From what I understand, he has been a long-standing professor at the university and he will be retiring shortly. So once again, a big thank you to him as one of his students. So without further ado, let's just get into this right now. Here we have a typical plot for a high-pass filter. On the left-hand side, we have the gain in decibels and the frequency at the bottom in hertz. And basically what's happening here is a logarithmic graph, so the frequency is increasing in tens or in decades. This high-pass filter happens to be a first-order filter in this case, so that means that it has a 20 decibel per decade change. So for every 20 decibel change in gain, there's going to be 10 hertz change in frequency. Usually, most filters have a cutoff filter frequency around -3 decibels. So in this case, it happens to coincide with a frequency of 1 hertz. And this happens to be the typical format you would see for a high-pass filter. This region to the left of the cutoff frequency is known as the stop band, and this frequency to the right is known as a pass band. So basically what a high pass filter does, it lets only high pass or high frequencies through, and it attenuates the lower frequencies. So this cutoff frequency here is 1 hertz. So anything more than 1 hertz will be let through, and anything lower than 1 hertz will be attenuated. On the other hand, we have a low pass frequency, which, as you can see, is pretty much the same plot, but it is switched around. So we have, in this case, the similar cutoff frequency at 3 decibels, coinciding with about 1 hertz. The difference between a low pass and a high pass frequency is the low pass frequency lets low frequencies through. So in this case, anything lower than the cutoff frequency will be let through, and anything higher than the cutoff frequency will be attenuated. Typical plot, it just starts around 0 hertz. The cutoff frequency has a similar roll-off rate of 20 decibels per decade. And yeah, once again we have the pass band and the stop band. So anything in the pass band region will be allowed through, anything stop band region will be attenuated. So just giving you a practical example of this right now, I'll be using my DDJ-SX to explain it. On this side, if I turn this filter knob to the left, it will activate the low pass filter, as it says LPF here. If I activate the high pass filter, it's done by switching the knob to the right. And basically what I'm doing is, in this case, if I turn the low pass filter to the left, I'm adjusting my cutoff frequency, and then taking it over to this side, and in that way I'm going to be adjusting the bandwidth, or I'm going to be adjusting the frequencies that will be played. So when this knob is turned directly to the left, the lowest frequencies are going to be played only, and all of the mid-range frequencies like the voices or mid-range for the drums and snares or whatever, they're going to be cut off. So only really deep frequencies or really low frequencies are going to be played. Right? Just give a practical example of this. I'm just going to be playing this instrumental that I have loaded. So when I activate the low pass filter, you're going to hear a change in the frequencies coming through. And then when you reset the knob to the neutral position, you're going to hear all the mid-range frequencies and high frequencies start to come back in again. On the other hand, if I do the opposite for the high pass filter, you're going to hear a similar thing happening. So the high frequencies are going to be played, and the lower frequencies are going to be attenuated. And the thing about these filters, the hardware filters built into the DDJ-SX, you can't really adjust any of the resonance or any other features that happen to be adjustable in some of the other mixers. However, Serato DJ comes equipped with built-in filter effects, so digital filters that you can use. In this case, you can adjust the resonance, shown here. Basically, the resonance, by adjusting your resonance, you're adding like a little boost. It's like adding a boost in the frequency before the cutoff frequency. So it sounds, in this case, it's going to sound, you're going to hear more of a swooshy noise as you increase the resonance. So let's give you a little demonstration of that. Right now we have the resonance turned about halfway, as you can see there. So when I activate the low pass filter and I increase, or I start setting the cutoff frequency, you're going to hear a higher swooshy noise. When I turn the resonance off, you can hear the difference. If you look at the high pass filter now, do the same thing. Set the frequency, the cutoff frequency to neutral position. And then when we increase it with the resonance off, pretty much get a standard increase. When we turn the resonance up, you're going to hear a bit more swooshing noise. And there we go.